good day, everyone. And once again, we're back together and we're still continuing with that November 2022 exam. So if you haven't subscribed, please click on that subscribe button. And of course, you can also join in as a member where you can benefit from all those wonderful perks, but also you support your uncle as he produces this wonderful content for you. All right, so let's see. Let's go through this question together. Right, so in this case, we're going to look at electrodynamics this time around. So please check out the other questions that came before this one. I've collected them in kind of a playlist so that you can be able to watch the entire question paper. Right, so they say to us the diagram below shows the initial position of the coil in a simple DC generator. The coil is rotated in an anti-clockwise direction as shown. Right, so in this case they say name the component in the generator that ensures that the induced current in the external circuit is in one direction only. So of course, being a DC generator, it means that current is going to flow in one direction, right? So the component that is responsible for that is what we call the split ring, okay? So those are split rings, or they are otherwise called commutators, right? All right, we'll discuss someday how they're able to do that. I hope I'll be able to do some shots on that to try and explain it to you. Right, they say, is the direction of the induced current from X to Y or Y to X? Now remember, ladies and gents, the first thing that I want you to notice is that, remember that field, okay, magnetic field always will move from north to south, okay, from the north to the south side. So given that this is a generator, we're going to use our right hand, and you place your finger, your thumb, the forefinger and the second finger being the middle finger, right, at right hand to each other. Right, now if you notice on this side here, on side XY, right, so just imagine side XY to be on the left hand side, say for argument's sake. Now, if it's on the left-hand side, you agree with me that it would be going down on the left-hand side because you're rotating anti-clockwise, right? So imagine it was flat like this, right? So in this case, what's happening on this side is that it's actually rotating downwards, right? So, right, remember that our thumb shows us the direction of the rotation, the direction of rotation. And then we know that our field would be pointed in this case towards the right, isn't it? So the first finger or the forefinger, right, would be pointed to the right hand side. So if you think of it, this would be your thumb here, okay, and of course your forefinger pointed to the right, okay. So in this case, what you would notice is that your second finger would kind of point in this direction here. So meaning that, so current would be moving from Y to X, okay? Right, so I hope I could be able to do that for you. But in this case, it would be from Y to X when we place them at right hand to each other. Right, so we know that current would be moving from Y to X. Okay, right. So our answer there is Y to X. All right, now let's go on to the next question. They say to us a maximum voltage of 90 volts is generated when the coil is rotating at a frequency of 20 hertz, right? They say write down the time taken for the coil to complete one rotation. Now, ladies and gents, I want you to just remember when we're talking about frequency in this case, right? So when you think of frequency, we say that frequency is 1 over period, okay? So in this case, we're just simply going to say 1 over 20, and that would be 0.05 seconds. So it means to complete one simple cycle, all right, it would take 0.05 seconds. Okay, so as a result, so in 1 second, it means that you are able to complete 20 cycles. All right, so they say to us the coil starts rotating from the initial position as shown in the diagram above, right? They say sketch a graph of output voltage versus time for one complete rotation of the coil. Indicate the maximum voltage and the relevant time values on the graph. Now remember, we're talking about a DC generator, right? So in this case, what we're going to have, okay, so let's just show that. Okay, so in the case of a DC generator, we know that we would have a generator that rotates in one direction, right? So this is what one cycle would look like. Okay, the peaks are supposed to be at the same point, okay, same position. So yeah, so those are supposed to be in the same position. Sorry about that. Okay, so we know that we would have a maximum voltage there, so that would be V max. Okay, and they said we should show the output voltage, so we know this would be voltage, obviously in volts. Okay, and that would be time. Okay, and that would be in seconds, right? Now remember, we said to complete one cycle, it takes 0.05 seconds, so that would be 0.05 there, meaning that we've got 0.025 over there, right? And then what else did they say we should show? Relevant time values, okay, of the coil, right? So they said the maximum voltage is 90 volts. So instead of writing Vmax there, I'm just simply going to indicate that as 90 volts. All right, so that is what our graph would look like. Now they say a wall socket supplies an RMS voltage and current. Okay, a 220 volt AC voltage is supplied from a wall socket of an electric kettle having a resistance of 32 ohms. They say calculate the average energy dissipated by the kettle in 2 minutes. Right, now we need to make sure that we have all the relevant conversions there. So what we're going to do is, remember, usually we talk about power in this section, right? But what is power? Power is the rate at which work is done. So that's energy divided by time, right? So if we can find the average power, if that's the route that you want to take, I'm going to show you another way, right? So what we need to take, or what we need to find is the average power. And we know, because we're talking about voltage and resistance, so it means that P average would be equal to V RMS squared divided by R. So we know that our V RMS value is 220, so that would be 220 volts, right, divided by the resistance in this case, which is 32 ohms, right? So let's try and calculate that. So that's 220 squared divided by 32, and that would give us 1515.5. This is watts, right? But now remember, what were we looking for? We're looking for the energy, isn't it? So we're going to go to this formula and say, well, we know what P average is. So as a result, we know what energy will be, okay, so divided by time. So it means if we're looking for energy, that will simply be power multiplied by time. Okay, so we'll take that value 1512.5, but we're multiplying by time. But remember, time was given to us in minutes. They said in 2 minutes, but remember that we need to always have that time in seconds. So I'm going to say that's 2 multiplied by 60. Remember, there are 60 seconds in 1 minute. So that would be multiplied by 120. Okay, so we get 181. That's 181,500 joules of energy. Please keep in mind that energy is measured in joules. Now, what I wanted to show you is that you could have opted to use the energy equation, right? So that would be energy is equal to V RMS, in this case, squared over R multiplied by delta T. And by using that formula, you would actually just do the calculation in just one step, right? As opposed to breaking it down into two different steps. But nonetheless, you still get to the same answer. All right, so that is how the cookie crumbles. And I hope you enjoyed this question. Please, ladies and gents, don't forget, to hit that subscribe button. Also, remember that you can join in as members. Okay, we've got a WhatsApp group. That's a members only WhatsApp group. Please click on the join button for you to be able to see. And by the way, all of that is in the description of this video. Otherwise, ladies and gents, I will see you guys next time. Sharp, sharp.